Okay, dear students, I am Rajat Giri, Associate Professor, Department of Mathematics, Government First Aid College, Tumkur. Today my topic is regarding successive differentiation. This is my first session. Okay. Already you are all familiar with the concept of differentiation in the earlier classes. What is the definition of differentiation? What are the notations we can use for the differentiation? Now I am going to the extended part of the previous year, the successive differentiation. I will consider first one real value differentiable function. Say y is equal to f of x. It's a real value differentiable function. Now I am going to differentiate this function with respect to x. We get dy by dx is equal to f dash of x. Is called first derivative. So derivative of y with respect to x. If this function differentiable again if I differentiate with respect to x, we get b squared y by dx is equal to f dash of x. Is called second derivative of y with respect to x. This is the second order derivative of the original function. If this function is differentiable again, I can differentiate one more times with respect to x. We get third order derivative, that is d cube y by dx cube is nothing but f dash of x is the third order derivative of y with respect to x. Again, if this third order function is differentiable, I can continue this differentiation up to n times. So that is e power n y with respect to n times. So is called nth derivative of y with respect to x. So this is the first order derivative, second order, third order. Similarly, we can define up to nth order derivative. So usually we use the notations for higher order derivatives like this. Notations for higher order derivatives is y dash, that is y1, y1 is the first order derivative, y2 is the second order derivative, y3 is the third order derivative. So similarly we can define, so yn is the nth order derivative. Usually we prefer these notations for higher order derivatives. Let me see one example. I will take one example. I will consider this. If y is equal to x cube minus 3x square plus 4x minus 5. So let us find y2. Okay. So y2 is nothing but second order derivative of the function y is equal to this one. Okay. If I differentiate this function, let us consider the given function is y is equal to x cube minus 3x square plus 4x minus 1. I want to differentiate this function with respect to x. So that is nothing but dy by dx, or you can use the notation y1 also, dy by dx, or you can say y1. So which is equal to, as you know that in the previous classes, the derivative, the standard derivative of a functions. Okay, x cube differentiation is 3x square, minus 3x square differentiation is 6x, 4x differentiation is 4, and the minus 5 derivative is 0 because of constant. Again, actually the problem demands second derivative, y2. So again differentiate with respect to x. So we get this square over dx square, or we can say that y2 is nothing but 6x minus 6 is the derivative. 4 derivative is 0. This is second order derivative of the given function. Let me see one more example. So let us take for example, if the function say y is equal to log of cos x. So let us find say y. Let's find y. The function is given, so y is equal to log of cos x. We need to find the third order derivative. If I differentiate once with respect to x, we get y1. So y1 is 9. So what is the derivative of log? Log differentiation, we have to recall. So d by dx of log x is nothing but 1 by x. This is, you know that. Okay? Now, here other than x, it's a chain rule. Log differentiation is 1 over cos x. Again, we need to differentiate the cos x differentiation is minus sin x. Now, let us simplify this. Y1 is equal to this becomes minus tan x. Okay. Let us differentiate once again with respect to x. We get y2. It's a second order derivative. Y2 minus, you know that tan x differentiation is secant square x. Secant square x. Again, I want to differentiate one more times because we need y2. So again, if I differentiate with respect to x, the derivative of y2 becomes y3, which is equal to minus, recall the derivative of secant square x. So that is secant square x differentiation is 2 secant x. Again, secant x differentiation is secant x into tan x. So now if I simplify this one, minus 2 times of secant square x into tan x. So this is y1. Okay. Derivative of y1 is log differentiation of 1 over cos x differentiation minus sin x. Now I am going to simplify, that is sin by cos, already you are familiar, that is tan x. Tan x differentiation is, you know that is secant square x. Again, secant square x differentiation is 2 secant x. This is chain rule. Again, secant x differentiation is secant x into tan x. After simplification, we get that is the result. Again, I will take one more example. So, I will consider if x is equal to a into cos theta plus theta sin theta and y is equal to a into just a into sin theta minus theta cos theta. I have taken this problem, x is equal to a into cos theta plus theta sin theta and y is equal to a into theta sin theta minus theta cos theta. Now actually it's a parametric coordinates. Okay, so it's a parametric coordinates. We need to differentiate with respect to the parameter. Here theta is a parameter. Here theta is a parameter because theta is connected with the x, also theta is connected with y also. Therefore, your theta is a parameter. We need to differentiate with respect to the parameter, this x. Again, y with respect to theta. Then find out dy by dx. After obtaining dy by dx, we can find out the higher order derivative. For this, let us find y. Or d squared by dx squared. I will take first. I will take that is first given this x is equal to a into cos theta plus theta sin theta. Now I want to differentiate this with respect to theta only because here theta is a parameter. Okay. Now x differentiation with respect to theta dx by d theta, which is equal to, now this is constant into function. A is a constant, cos theta differentiation is minus sin theta plus, again theta sin theta is a product rule, These are all the rules and regulations as you studied in the earlier classes. Okay, it's a product rule. The product rule says that is theta as it is first function, derivative of sine is cos, plus sine as it is second function, derivative of theta with respect to theta is 1. Okay, let us simplify. This get cancelled. So you get dx by d theta, that is a theta cos theta. This is dx by d theta. Now let us find dy by d theta. Now if I differentiate this with respect to theta, now y differentiation is dy by d theta. Dy by d theta, which is equal to a constant into function. Sine differentiation is cos. Again minus theta cos theta is there. Again I have to use, that is the product rule. Minus of, I take long bracket. First function is theta. Cos theta differentiation is minus sine theta. Okay. Plus second function as it is cos theta. Derivative of theta with respect to theta is 1. Close the flower bracket as well as square bracket. Now let us simplify. A into cos theta, open the bracket, minus plus theta sin theta, plus minus cos theta. After simplification we get a theta sin theta. This is what? dy by d theta. Actually dx by d theta is a theta cos theta. dy by d theta is a theta sin theta. Actually, I need y2. Before finding y2, I want to find y1, first order derivative. Next, already we know that when theta is the parameter, then dy by dx becomes dy by d theta divided by dx by d theta. When theta is the parameter, so we find out dx by d theta. Just to substitute here. What is that dx? Sorry, dy by d theta is a theta sin theta divided by dx by d theta is nothing but a theta cos theta. So a theta get cancelled, we will get tan theta. This is what dy by dx. So dy by dx is tan theta. Now I want to differentiate this. With respect to x, not with respect to theta. You should take very care here. Most of them will commit the mistake here. Here, that is dy by dx is tan theta. Actually, I need y2. Y2 is nothing but d squared over dx squared. I need y2 is nothing but d squared by dx squared is equal to y. This is a required. Okay, the function in terms of theta is there. Now I want to differentiate this dy by dx with respect to x. With respect to x. With respect to x. Now dy by dx differentiation with respect to d squared by dx squared. Tan differentiation is secant square theta. Be careful here. Theta differentiation with respect to theta is 1. But we are differentiating with respect to x. Therefore, theta differentiation with respect to x is, that is d theta with respect to x, that is d theta by dx. Now we need to substitute for d theta by dx. Already we know that dx by d theta, we find it. So already we know that dx by d theta we have. What is that dx by d theta? A theta cos theta we have. A theta cos theta we have. The reciprocal of this one is this, correct? The reciprocal of this one is, I need d theta by dx. The d theta dx becomes a theta into cos theta. Let us substitute here. Secant square theta into 1 over a theta cos theta. So which is equal to 1 over a theta. Again 1 by cos theta is nothing but secant theta. Secant square into secant is secant 2 theta. This is your y2 or d squared over dx squared. Okay. Please take care here. Differentiate with respect to x. Tan differentiation is secant square theta, theta differentiation is d theta by dx. Thank you.